We are joined on Tool or Die today by David Moody, who is the founder of Foundry Lab, which is a new casting process and company, which we're going to get way into.
Perfect.
But take us, from so you were born in South Africa. When did you guys move to New Zealand?
Yeah, then I was 12.
Is that a common move from South Africa to New Zealand?
Yeah, so South Africans go everywhere that was part of the British Empire, right? So you find them in Australia, Canada, New Zealand, the UK.
What was your, what did you grow up doing as far as, things that took you towards the idea of wanting to build stuff and do manufacturing?
Dad's an architect, so I'm obviously very much on the practical side of things, creative side of things. We always had a very well-stocked garage with we had the kids' vice and we had Dad's vice, so we would build stuff and I burnt a lot of stuff, built a lot of stuff. It was always, bow and arrows or toy guns or, sticking a sail on a skateboard and trying to get blown down the street and that sort of thing. So, always been, I guess, on the practical side of things, and on the creative side of stuff.
I've always said, based on my childhood, that there's no better toy for a young man than a gallon of gasoline in a milk jug. You can do a million great physics projects.
And some parents who weren't too worried that I was going to, become an arsonist. But I think the other thing as well, like my dad built a houseboat. So most of my childhood was spent getting, weekends getting roped into fiberglassing or, sanding.
So you are reinventing the process of metal casting. Now, for people who don't know what metal casting is, it's when you take a mold and you pour some metal in it and it becomes a metal part. However, not a lot of it is around these days or as much as it used to be in the Western world. So tell us about your process. Like, what have you actually built?
Yeah, so I think you're right. So casting is, I think the first casting we know of is about 8,000 years old. I went to a display in the Met in New York, and they had Egyptian casting. And they was doing it the exact same way as we do it now. So there was this really interesting. It really hasn't developed far in the last 8,000 years. And you're right. In the West we've lost it. There's only about 25% of it left in the States. It's been offshored. But I think the statistic is you're never more than 6 foot from a casting. They tend to be behind things, underneath plastic shells or in your walls, or when you open your door handle's got between 6 and 10 castings in it. So it's everywhere. You're just not really aware of it.
We're going to continue to use casting probably for another 1,000 years. It's a very useful process. And you can do it with lots of different types of metals. It's not just iron. You can do it with almost anything if you get the heat and the base right. What was missing that caused you to say there needs to be a new process and a company around it for casting specifically?
Yeah. Okay, cool. We might have to go back a step here in that I went through university and studied industrial design. So I got a degree as an industrial designer and then spent 15 years in consultancies, which I really loved, right? It was, and this kind of led towards the startup idea. In consultancy, you're getting new projects every couple of months. You're doing all your R&D. You're trying to figure out how you can help your client beat the competition. So very much this is like a setup for becoming a startup. What was happening? So I'd done this for quite a while. Then I started my own consultancy. And so in the last sort of 2 or 3 years, we started getting more and more customers saying, can you design me this part or this product? And it would need a casting. And so the client, and this is, maybe it's because we're in New Zealand where, it's typically smaller, but the client would be, they would say to us, great, we love the design. Can you make 10 so that we can do some testing or so that we can get this thing, certified or qualified? And when, we do a lot of plastic injection molding. And so when it's plastic, that was fine. We could 3D print it and test the part and get a pretty good idea that we'd got the design right. When you've got casting, it's a completely different story because a client never specifies casting unless they want a certain strength profile or a thermal dissipation profile. So it's always a critical part. Otherwise, you would go plastic because it's cheaper, right? So customers are asking for these parts. They've got castings. I say to them, hey, I can't prototype a casting because the tooling for a casting is horrendously expensive. So let's show you some prompts. The tooling for a part like that might be $50,000-$60,000 upwards, right? So then you go, okay, well, I've got a couple of options. I can CNC machine, so take a block of metal and subtractively, remove it until I end up with the part that I want, right? I mean, you guys are tool and die, so CNC machining, but that gives you a part that's in a different alloy and it's got a completely different physical profile, right? So
Right.
if
It's not
you
the
did,
same thing.
it's not the same thing, especially if it needs to be qualified. So let's say you're crash testing a vehicle. If you've CNC machined all the componentry that should be cast, you're going to get normally a much stronger part than you would in the casting. And so we were giving clients two options. One, I can CNC machine it and you're just going to have to deal with that, or you're going to have to pay the tooling. And in cases where this part was critical, they would pay the tooling. So I was sending clients off to spend $80,000-$100,000 at a time on parts or for molds for parts that I wasn't entirely sure were going to work, right? And so that is your neck on the line, especially if you're the company owner. That's your neck on the line, right? You're taking a ton of risk doing that. And I guess industrial designers get taught that you're the best thing in the world and you can do anything you want, so which is dangerous. So I just looked at it and went, well, this is stupid. Why are we in this day and age? Why do we not have a way of getting to castings without paying for tooling? So that was kind of the start of it. Going, sorry, my light keeps changing. We got cloud cover going by.
It's all good.
But I was just looking at this, going, essentially, I was trying to fix a problem for my clients. How can I get them short run castings or prototype castings that were going to be physically the same as what they needed in production?
When you talk about a casting, the inverse, the mold costing 50 to 100 grand, is that because there really is only one type of casting where it's either it's good enough to do a casting and that one would be good enough to make 10,000 parts out of that same mold? Or is it just the setup fees and not the actual mold itself?
Okay, the casting world are gonna hate me for this, but let's say that there's pretty much three ways to cast, and we've been doing it since forever. You get investment casting, which is you make the shape in wax, you dip it in ceramic, and over about a week you build up a ceramic shell on, then you melt the wax out and you pour the metal in. And that's what the Egyptians were doing, right? That's what I saw in the Met, using beeswax. Your other option is sand casting. Oh, sorry, the investment casting, you can get really fine detail, thin walls and things. Your next option is your cheapest option, sand casting, and you make a positive shape and you press it into the sand and you get the impression of what you want and you pour the metal into the impression. That can't do fine detail. And it also has because sand is an insulator, your metal cools down very slowly, so you get a very weak part, relatively. So, and then your third option, which was only invented about 150 years ago, is die casting, which is cut a steel tool. So you get your void in the steel, and then you pump your metal in. And now here comes the crux of the problem that we had to solve. That's fantastic, except for the steel wicks all the heat away. So your metal freezes in under a second. Some of the ones that we were working on, we were getting 0.3 of a second before the metal's frozen. So the way to get around that then is to increase your pressure. So if you can pressurize the metal, which is what die casting is, then you can spray it into that cavity as fast as possible. And then you're starting to play this game. It's this death spiral where you're going, well, more pressure means my mold has to be thicker to handle the pressure. And it just kind of, you end up with these extremely expensive tools, able to do very fine detail, but it's cost me, in some cases, we're working on stuff that's $250,000 for a tool. I know if you look at the Tesla guys, they're doing multi-million-dollar tools when they're starting to get big. And so that was kind of this problem in that we are mostly designing for mass manufacture. So then you would head towards these sort of permanent molds. And you, especially at the moment, lightweighting is a big deal. So you're trying to make your castings as light as possible. But therefore, you're going to need this really expensive tooling to set.
Now, I'm absolutely going to interrogate you on using your machines to make parts at scale, because that would obviously continue to fill the gap. But so that everybody understands the process, I'm going to explain it to you, and then you tell me where I'm wrong. Somebody can take a part from CAD, send it to one machine that you've built, and you effectively 3D print a mold. It's like 3D printing sand, for lack of a better a material. And then once that is done, you have another machine that is actually doing the casting, where you can control the heat and the flow with a lot more fidelity than a traditional process. How close am I?
Pretty close. Pretty close. Right. I've got props here. So let's get into it. Right.
Okay, let's
So
see.
yes, you take your CAD file, and then you have to design a mold. So at the moment we're working on a way of automating that. But at the moment you design a mold. So here's your two mold house. Sorry. It's printed in a ceramic. So it's a proprietary ceramic. That's a nice hard mold. It is much, much finer detail. It's not an earthquake. It's just noisy. Much finer detail than sand printing. Okay, so you've got your mold, you've put it together, you're taking your alloy, so in this case aluminum, dropping it in, and then putting it inside the furnace. So behind me here, this machine, that's actually the cavity there. So that lifts up, and you place as many of these as you can fit in. You push the button and you walk away. The idea, and this is because I'm an industrial designer and it's user first, right? The idea was, how do I do casting without being a foundry? I'll come back to that in a second. Okay, so what we then do is we direct energy at the mold, heat the mold up, the metal melts and it flows through, and then here's one I prepared earlier. There we go. Then you've got your casting, you pull it out. You'd obviously have a sprue on the top that you cut off, and then you've got your part. The key thing here is this is indirect 3D printing. So this is a casting. So we're not printing the end component. We're printing the molds, but the end component is still cast. So it has the properties of a casting. We use the same alloys as the casting, and which is why we're getting to within 95% of, or in some cases, better than the production casting.
And not to talk your book for you, but even in commercial castings, to my understanding, there's quite a bit of variance in casting in general. So even if there is like a long established process, a lot of times the parts that are coming off those lines have a lot of variance from metal quality, trying to maintain heat. There's a lot of factors in there.
Absolutely. So casting to date, and again, I'm sorry, casting industry, don't hate me, but it is fairly crude. It's fairly tribal. So as the weather outside changes, your casting changes. As the humidity changes, the outcome you get is different. And so what we've done is digitize the whole process. So everything, the environment that it's in, the time it takes to heat up, the time it takes to cool down, how long it's sitting in molten, we control that all. So this machine here, you can't see it, the door's open. It's got a screen on it, right? And it is push button, and then the machine looks after itself. So what we're working on is a machine that's agnostic of the user. So it doesn't matter if you have had 20 years in Foundry service or you're 2 weeks into it. The machine just it needs to be told what to do, and then it does the process. So that I think is a key thing that we've discovered for right now in history, is the ability to cast without the workforce. And so if we go right back to where we're talking in the beginning, we're saying there's like between 20 and 30% of the industry has been offshored. There is this huge push in the US, which is why we are, US focused. There's this huge push to bring manufacturing back, and there is the skilled worker shortage, massive issue. And America can afford to buy machines. That's absolutely not the problem, right? The problem here is we've got no one to run them. If you look at the demographics of the people that are left in casting, there is an uncomfortable amount of them that are in their late 50s, early 60s. And we're seeing this across, the whole reindustrialize, rebuild movement. We're seeing this across all of manufacturing. Casting has probably been worse hit than anyone else, worse than CNC has been hit. It's just basically gone offshore.
Why? Why do you say that?
Okay, so we'll do some David theory here, but the way I see it, what happened was casting. Once you've paid for a mold, casting is cheap. right? And once it's up and going, I think we thought of it as dumb. So, right, let's give this to other people. They can do the dumb stuff, and we'll retain the knowledge, and we'll retain the innovation and the creativity. And the reality is that's flawed thinking. That the minute you stop making, you stop innovating. And so what's happened in America, and again, sorry to, we have got really good at getting you your products overnight, right? We've thrown all of our effort at things that actually don't really matter. And we've lost this innovation in manufacturing. And so you give someone else the manufacturing, you give them the know. Like, we literally taught other people how to do this, right? And then they went, what if we change this? What if we change this? And then all of a sudden they're innovating, and we're not, because we're just not involved in the process. We're saying thank you for the product, but we've got no idea how to make it anymore. And so then you come to a point in history like now where things are getting politically heated, and there's concerns of war and things like that. And there's, well, how do we build a deterrent? And then all of a sudden you realize that the West is largely toothless now, because we actually can't. We literally are using China to build the war machine. That's not going to happen for very long. And so then you're going, well, okay, well, how do we get this stuff back? And the immediate thing is, well, we'll buy the machines. And you go, well, actually, we just don't have the people to run these machines. I was in the States for 7 weeks just before Christmas. In that time, I think 4 or 5 foundries shut down. So these things are still shutting down. There's a lot of work coming back to America with tariffs and things, which is fantastic. But what do you do when your workforce is disappearing? And so this is we developed a technology that allowed me to cast without getting burnt, and turns out that's what the country needs. That's what the West needs right now. So kind of we've timed it very well, I think. What we have to do at this point, though, is build trust, because this is an entirely different way of casting. When metallurgists see it, they mostly argue with me to start with, because this is not how you cast. Like, you don't put metal inside a mold and put it inside a microwave or whatever. So it is going to take some time. But what we're now doing with independent testing is we're starting to show our results of the castings that we're getting, and we're showing actually that we're beating, we're well ahead of sand casting. We are in some points exceeding permanent mold casting strengths. So it is becoming really interesting, and there's a shift in our thinking as a company from, hey, we can prototype and be really close to another casting style, to saying, actually, we can cast better parts. So why are we even trying to copy anyone else?
You're getting to or let me skip ahead to a question, which is, I understand the core principle of at least how you started the company, which is, if we can remove the prototyping cost for casting, then it increases the cycle of development, and that still allows for the old school industrial casting process to be in place once it's really locked in. And yes, it has staffing problems, et cetera, but there's that. But if I came to you tomorrow and I said, I actually want to make 100,000 parts with your machine, where are you at in the development cycle? What are you learning about the possibility of that?
If you came to me tomorrow, I'd say you need to go back to traditional manufacturing for that sort of quantity. If you came to me in 5 years' time, I hope I would be saying, give me the work, thank you. We have line of sight towards that sort of quantity. But at this stage, no. I think I get asked this question a lot, and I think that's what you're digging at. Is this going to replace all casting as we know it? And I think the reality for a long time yet is that die casting, that's what you want to do if you want to go mass manufacturing, if you're wanting to make millions of parts. And that's, it is fast. We're talking cycle times in die casting of sub 30 seconds, and it goes lights out all day, all night, just going. There's a reason why we use it. I think there's another thing here, and that's maybe a naivety of thinking, in that there's this idea that we're going to onshore. Sorry, the noise in the background. There we go.
It just adds color.
That's okay. We know you're real.
It's New Zealand, but we don't earthquake all the time. So I completely lost my track there.
You're talking about building up to a certain place. Yeah.
And is reshoring real?
So absolutely, it's real. I think what we're seeing though, or it's naive to think that we're just going to bring everything back, because in the end, the dollar, what it costs us, is paramount, is foremost. So if we can't do it in China, then everyone's going to move it to Vietnam, or they're going to move it to Mexico, or wherever it is. I think for mass manufacture, right, for doing these things at huge quantities, what I think is coming back to the US is short run and bridging. So when we're talking to customers, we're seeing customers saying, hey, I have got production in China, I have to move it. I will have a blackout. I'll have a shadow of 2 or 3 months whilst we set up in Mexico, let's say. And what are we going to do in that interim? And so we're seeing a lot of companies interested in this technology saying, I need to be able to bridge between these two. I want to have, and we're seeing a lot of this sort of post-COVID shock where they're saying, well, I need the ability to manufacture at least short term until we can get our production up. Now, I'm not saying that we're never going to go to mass manufacturing in the US. I think it's going to take more bravery. I think at the moment, your government is incredibly brave to do tariffs. That's extremely unpopular. But that's how you force manufacturing back, right? And that's how you force innovation. So from that perspective, I think that's very interesting. And that's why we are, so we're moving across to the US. We're a US company now. We've flipped, and not Europe, because Europe's not doing this. Europe's still looking at the problem going, what are we going to do? America has gone, we are in trouble and we're going to fix this. And so this has been this really interesting from an outsider, from the international community watching and going, that's not talk. That's actually going and doing it. And especially what we're seeing with defense. So we sold our first machine to the Defense Force. Defense is going for this stuff. They're saying we cannot afford to be toothless. And we know that we don't have the ability, inside the country to deal with this. So we're going to start buying technology. We're going to start supporting technology. So it has been a really interesting ride for the last sort of 6 to 12 months.
And you, earlier you were saying, that I think exact words were that we are in danger. Are you talking about the collective West in terms of manufacturing? Is that what you mean? Okay,
yeah,
so
yeah,
there's a fair bit of talk in the U.S. about the threat of China and cutting off supply chains. But having been in New Zealand for the first time myself recently, I was struck by how much closer it is to China. Like, is there like an imminent sense of threat? Given what we see in the news, the exercises in the Straits of Taiwan, the South China Sea. Like, do you feel like an imminent sense of threat in New Zealand?
No, and this is a really interesting thing. So I know that China just did some wargaming off the shore of Australia, which is pretty close to us, right? New Zealand, I don't think has woken up to this. We and I have to apologize. New Zealand lobs a lot of criticism at the US. Hey, we don't like your foreign policy. We don't like what you're doing, but we would like to sit underneath the shadow of your protection, please. Which which has been an interesting coming from this culture, which is I wouldn't say anti-US, but it's like, hey, we're telling you off for what you do. I've been on a fairly good journey in the last 2 years, realizing how hypocritical we are as a nation. We literally, our shipping, our way of life is protected by the US, and we're quite happy for you to do it. We're quite happy for you to fight ISIS. We're quite, there's all of this sort of thing. We're quite happy for you to, keep shipping lanes open and blow pirates out of the water. And so it's been this really interesting. I don't think New Zealand has woken up to it. Australia absolutely has, and they're purchasing submarines through the US, and they're working with you. I think some parts of New Zealand are, but it's only just starting to wake up maybe. And I think this is for us as a company, saying actually we have this ideological. I have this ideological bent here, in that the New Zealand that I love is only existent underneath the protection of the US. That's what the conclusion I've come to. So then I'm looking at it and going, well, what can I do to help the US? And I don't know, it's very ideological. But if I can produce a system that gives the US the teeth to be a deterrent, I think I help keep peace and stability, at least in my region. So it is this really weird thing, and this is New Zealand. It's a small country. We have almost no manufacturing. Looking towards the US and going, actually, if we put this in the US, if we help the US, this is the best way forward for us as a company, but also for my family. So that's kind of the motivation behind a lot of our decision to go US focused rather than Europe or Japan or China.
What is it like to be, though, somebody that is from outside of the U.S. that's walking into the U.S. where DoD is one of your customers? Like, just culturally, like, how are you responded to? Are you taken seriously? You got a little higher hill to climb to build some credibility? Just what's your experience been?
But let's be clear, though, I met David was I went down to New Zealand with a Rob Conabier and a crew of American VCs and got to meet the most fascinating founders in New Zealand, and David was one of them. So, yeah, I'm actually, I have a huge soft spot for New Zealand now that I've been down there. But go on, you were saying?
So I think I've been welcomed with open arms. I think because we've got a technology that the US actually sees as being important. So that's been fantastic. There's so much I can't say. The defense community has been for us so far amazing. Really haven't felt at all like we're an outsider. It's more like, hey, we're in this together. What can we do? How can you help us? Meeting some really high, I guess, political figures and talking through with them. And literally the question has been when we get on the call, it's like, David, how can America help you? What can we do to get you here? What can we do to help? Which has been fantastic. So I think from that perspective, you should be super proud. There's not been a hey, America is the only one that can fix the problem. There's definitely a look to collaborate. And I think we're seeing that like with Australia at the moment, right? Lots of collaboration with the Australians. Sometimes we're just seen as an offshoot of Australia.
The reason we found ourselves in this spot and the lack of manufacturing is because of our own fault. We did outsource a lot of this stuff through the 70s and 80s and 90s, and then built up the countries that now, China in particular, that we feel like could be a threat. I am still my opinion is still, I need more information to have a good understanding of what China's agenda for the world is. But that's why it always comes back to me, and it's a big reason why Alex and I did Tool or Die, is I think that the geopolitical threat is real. And I think that the Western order, if the U.S. is going to pull back and we're not going to protect the shipping lanes and we're not going to be the world's police so much as a factor. But I also think that America lost something as a cultural identity when we stopped building things in this country. And I hope what you're hearing from a lot of Americans that you're dealing with is a memory, awakening that memory and going, it has a bunch of different reasons why it's beneficial to us, but doing it itself is its own good.
Absolutely. And I think for me as well, right? I have no, I don't want to be involved at war at all. I would be devastated if our machine was killing people, right? I'm looking at it from a deterrent perspective and going, ideally what America needs now is to show us strength, so that there is, because I don't think we need to go to war, and I hope we don't need to go to war. But if people are saber rattling, I think we need to be able to pick up our own saber and rattle it back. So in agreement there. And I think you are right. I think the US lost a bit of its soul. I mean, if you look, and again, sorry, don't mean to go back to war, but World War II, the industrial might of the US, right? It was you produced more steel and more castings than everyone else combined, right? And now you do almost none of it.
Well, Dave, as an American, I have to say I have no qualms about arming up and getting manufacturing back here, so deterrence can be the name of the game. So, what do you need? To get to the next level for your company? Like, what did you say to the admirals? Like, who said, well, "Let's get you over here"? Like, what can we do together?
The thing, especially defense, if we're talking defense, and I don't think that's my biggest market. I just think it's the most hungry right now, and it's the most willing to actually take risks on people like us. Defense, especially, is needing higher temperature alloys. At the moment we're running aluminum, zinc. We just started brass. brass and bronze, but they're wanting the Inconels and the stainless steels and the high temperature stuff. So, and that takes money, right? And so that's the kind of there's this you're always coming back to money and going, look, we need to develop more technology. We need to have more experts on hand, and that's part of this. This move to the US is allowing us to get this access to these industry experts. But the big thing for us was connections. So if you're coming as an outside company, looking back at it, it's a small miracle we sold into defense. We all have funny accents. We're not domiciled in the US. We're a US company, but we're not domiciled. And so actually breaking through all the bureaucracy and getting to that point as fast as we did was a small miracle, I think. But now I'm starting to discover that selling into defense, that's a whole nother game. That requires specific knowledge.
All right. I want to go into more nerdiness about the process itself. So one of the things we haven't touched on is that your process, you said you're using microwaves at the moment to actually heat the metal, and that it works incredibly fast. What are the advantages of that than the way that traditional casting work?
If we just back up, we have a microwave version, we have a non-microwave version as well. So this is a machine that's actually going to a customer. These ones are non-microwave. When we first started, I was very fixated on automotive. There was definite use case in automotive because they had to have as close to identical as possible a part. And can't tell you who, but you could probably work it out. There's an automotive company that likes to move fast, right? And they said to us that the faster you go, the better. So we went after microwave. We could turn around in less than 8 hours with a microwave. It is complicated, and it's expensive. And what we discovered was there's only so many people who are prepared to pay for speed like that. If you look at the quantum, we're saying we can get it to you in 8 hours, and the alternative is 6 months. Then all of a sudden, 24 hours doesn't. 24 hours is fine. And so we were starting to get that response from customers where they were saying, actually, the speed that you guys can move is ridiculous. We don't actually need that speed. But yes, microwave, and we're still doing a lot of work, spending a lot of money on microwave R&D.
Well, can you say what your current machines then use? Like, is it still like an RF thing?
No. So resistive coil. So we have one machine that's a hybrid. So we've got a full microwave version. We've got a hybrid version, which is microwave pumped in and resistive coil. And then these ones, these machines are small, so they only do a 1 foot tube. And so therefore we can still move fast enough without microwave. But if you're building in a powder, you're basically building in an insulator. So if you're trying to heat that powder to set the molds, it can take us 10 hours plus just to heat through the powder, right? Microwave gives you this ability to pierce straight through and heat instantly. So what is a 10, 12-hour process with generic technology, with microwave I can do in an hour. And that was the kind of this key thing. It was like, okay, well, we can just move so fast with microwaves.
And I would presume that you would have some possibility to direct different levels of heat to different points with the microwave.
You can start steering and you can start doing some interesting stuff. Absolutely. Yeah, I mean,
I'm not trying to belittle the shipping machines, but it is. I mean, it's casting has worked by applying heat generally to things for a long time, either to the substrate in the mold or to the metal itself. And that's kind of what you're doing now with a resistive, like a heating coil, effectively. But it's, from a nerd perspective, extremely interesting to be able to say, within this whole thing, I can direct different amounts of heat at different places and times as the metal flows.
Correct. Yeah. Okay. So the other thing, if we're going to get nerdy, right, is when we use microwaves, we're directing the microwave energy at the mold. So with resistive coil, you've got your mold in the middle and you are heating the air between the two, right? And it slowly passes its way through. So convection. We run under vacuum, so actually we're radiant heat. So it's even worse. So when you go microwave, you're shooting straight through that gap, and this becomes your element. And all of a sudden, you're using a whole lot less energy because you are just heating up where the metal is. And then you're not heating the whole space. And what, one of the key unlocks with what we're doing, right? So if you do normal casting, like you explained at the beginning, casting for the last 8,000 years is melt metal in a crucible, pour it into a void, and get your shape. The hardest thing with that is, can I get the metal to flow everywhere in that void before it freezes? Right. So that's what you're chasing in casting. That's the key physics thing that you're dealing with. Or two. One is, can I fill the mold fast enough? The second is, can I cool it fast enough? But if you cool too slowly, you get large grain structure, therefore you get very weak parts. So when I came to look at this thing, it was like, hey, this is just really stupid. Why are we doing this the worst way possible? And it's naive, absolutely naive, right? But going, if I heat the mold, if this thing's hot, the metal's going to flow through and sit there in a liquid form, and therefore it's not going to freeze. So I can fill down to that 0.5 millimeter that we did recently for the customer. I can fill anything. I'm no longer fighting physics. Physics is now working for me. So casting for the last 8,000 years has been, can we fill it before it freezes? We're now saying, well, that's done. Let's just keep it hot until it's filled, right? So we have no pressure, and we're getting this 0.5 millimeter wall thickness. Sorry, and it's geeking out that your casting
That's what I
listeners
asked for. That's what I
hopefully will
wanted.
be geeking out with me. Right. So now you've essentially got zero freeze, zero shut off. So then all of a sudden these really interesting things become available to you. You're starting to now blur the line between what 3D printing can do and what casting could do. Because you're saying, I'm going to flow. So even if my design is really bad, I'm going to fill the mold, right? So I think we have the potential to have a much easier barrier, lower barrier to entry in terms of, well, the mold is going to fill. There are other things that you have to deal with, like shrinkage as it cools and things. So, but you're now saying, okay, the mold is going to fill. And then we control the speed it cools down. So in this particular system, actually, you can see some of the gas quench on that side. We heat the mold up, wait till it's completely filled, and then we're firing a freezing cold gas at the mold and cooling it down. And so then we can control the speed. So if you want it to mimic a sand casting, and as I was saying, we're getting away from mimicking, but if you want to mimic a sand casting, you cool it down slowly and you get it a week apart. If you're wanting to mimic a permanent mold casting, you cool it down fast. And so there's all of a sudden these levers that no one's ever had before. When I was at my design firm, right, if we were designing something like this, we wouldn't go for the thin wall, right? We would go middle of the road. We would design the safest possible, because the tooling is so expensive, you can't afford to get it wrong. You also can't afford for the client for it to be wrong. So we were designing with factors of safety, et cetera, and also make sure that you can get flow in the mold. When you don't have that problem anymore, we're now saying, what I believe we're going to see in the next five years is designers starting to push the limits and going, well, actually, let me try it. Hey, I can have 3 of these by tomorrow, and I can find out whether this stuff works or not. Does my design work? And then all of a sudden, we are using far less material, which is great for sustainability. But I also think we start saying, well, because it's now less material, it's cheaper to make the part. So I'm going to look at metal instead of plastic. And this is infinitely recyclable, right? That's just going to go again and again and again and again. And I think we end up in a better place as a world when we've got better control over casting.
You're moving the company to the U.S. What does that look like? Because as we are, for those that aren't watching on video, David is sitting in his shop with a not giant machine, and if we're honest, but it looks like 2 or 3 good-sized refrigerators put together. So it's a pretty big operation. What does it look like as you're moving to the U.S.?
Yeah, okay, so we have been focused on selling machines to customers, and so we've passed the $1 million mark, which is nice. Get out of R&D and actually into production, making parts. So early adopters. What we've discovered is everyone we show the technology to is excited, and then says, can you just make parts for us until we are comfortable with this technology, right? And what we're realizing is we've got to build trust. We've got to build trust in the industry. And so we're doing a lot of stuff now. We're just doing a webinar next week where we're actually just showing results and independently verified results and things of the castings. But what's definitely going to make our lives easier is to run this as a service. So people can come and try the technology. We can do your short run of 100 parts or 1,000 parts or whatever it is that you need, or 3 parts. but you can then take the stuff away and you can slam it into a wall like some of the customers we've been working with are doing and go, hey, that's actually pretty much exactly what I need. The idea, hopefully, with that is that we're going to build trust in the industry, and then people are going to start to say, right, I'd like that capability in-house that we believe is better than the way we currently cast, right? So we can then do two things. One, we can do Foundry as a service, the FAS that we're doing now, and we can just try and set up as many of these as possible and try and make as much money as possible. Or we can look at the bigger context and go, what are we actually trying to achieve here? We're actually trying to rebuild an industry. I don't think I can build enough foundries fast enough to rebuild the industry in the US. So if you look at China, since the 80s, since we started offshoring, they've been opening 600 foundries a year. That's if on average, right? If we open 4 foundries in a year in the US, that would be completely backing the trend, right? But that's doing nothing. No, we need 10,000 foundries in the US to actually be anywhere near competitors. And so my thinking is, yes, I can open up foundries as a service, and I will. What I think though is we need to get this technology to the point of need, and it needs to be disseminated. It needs to be everywhere. Wherever there is a need, people need to have a machine. And that might be in foundries, but that we're seeing quite a lot of companies directly saying, hey, I don't want to start up a foundry, but I want to have access to casting. And so we're seeing companies starting to, purchase these machines and they're on our waiting list for machines and things. So I think from the ideological point of view, we actually want to sell machines and get them everywhere. It might take some time for us to get to the point where people will trust it, and therefore we'll run it as a service until then.
So right now, if I wanted to use it as a service, are there machines that you have in the US, or would I have to have the parts that you're making for me sent from New Zealand?
So we've got a demo center in Fremont, just outside San Francisco. But we generally will make machines. Well, we'll make parts here, and that's been part of a really interesting thing, right? We've got ITAR regulations and things, so it becomes very difficult to be outside of the US if you're working in defense. And so the idea was, and that's what we're doing now, is to re-domicile in the States. So right now, I can make you some parts. It's going to be done in New Zealand. Hopefully Q3, Q4, we will have a reasonable capacity in the States. We're looking at having between 4 and 5 machines sitting in our Foundry as a service. And then we'll be able to do quantity, right? And I think the key thing here is this thing can move at speed. We have to have enough capacity to move at speed, but we have to grow to that capacity. I think in terms of investment and things, we need investors to understand the opportunity, and so this is just unfortunately you have to take these steps. Like ideally, I'd love to come out and say, hey, look, we've got this new technology, throw a lot of money at us, and let's just go. And unfortunately, I think it also doesn't help to be from another countries, but VCs look at that and go, well, show me your market first. So this is our opportunity to show the market, I think, and the idea is at the end of sort of 18 months of doing this, we hopefully can then start doing this at speed, have gained the trust of the country and of the industry, and then
The good news is that what you're trying to do as a model is not unknown, right? You start as send, cast, send, and you prove out the service. But what you're also doing at the same time is honing in on commoditizing the units themselves. And you're in a very similar spot to the arc that 3D printing has been over the last 15 years. And with you, not disagreeing with you on the actual end user utility of 3D printing in industrial manufacturing, but what happened in the arc of that is that it was very popular. Everybody realized then a year or two later, it sucked and it fell off the map. And then it went through like about a decade while the tech actually got very good again and very cheap and universal. And now it's back in a way that, it's probably where it will be forever until their material science changes. Or in all honesty, it'll be something that's like a hybrid between what you are doing. And I know you like to don't want to position yourself this way. You are doing 3D printing. You are but it's in the same way that you are putting atoms together in a new way that is highly evolved and digital. And I think you're going to be on a similar path. All you have to do is prove out to people and get your price of your units down so that it does make sense eventually for, Boeing to say, you know what, we're tired of doing this as a service. Give us 50 of these, and you become a Sony or an ASML at that point.
Yeah, absolutely. I think that is, and I think it's fair. We have a very similar market to the 3D printing market, so we will always be, judged against it. And I think at the moment that's a negative thing, but hopefully that's gonna build towards positive. But yes, I think as we prove the technology, it's the hope that the Boeings and things are going to pick up on this.
I think it's fascinating stuff. Like
Yeah.
I do think you're onto something. It's what you are also running right up against, for better or for worse, is the pinnacle of capitalism done the American way, which is even if you have an amazing idea, you also have to be a great businessman and a great modeler and steward of your resources. But I do think you're onto something, because you're fixing a problem that no one else is fixing way down at another price point and at an end of the spectrum that there just isn't a lot. CNC really is your only competition, and that's useless. That's great for like to like part. I need to make one part or another part, but casting is different than CNC. Like, it's just a different process. I think you're onto it.
Speed multiple that CNC won't keep up with. Yeah, absolutely. Can I just jump on one thing there? So there's Executive Order 14017, so it came out of the White House, and it was, hey, we need to rebuild manufacturing in the US. What's really interesting, and no one knows this, I talk to a lot of people, out of the back of that executive order, you've got 4 industries are identified. First one is kinetics, which, missiles and bombs, and understood.
I like those.
Those ones are good. They keep us safe. Second one is microchips. Everyone knows, the CHIPS Act and all that, out the back of that, right? And that's fundamental for keeping America ahead in technology. Third one is batteries, which, again, everyone knows batteries. Fourth one is casting. And absolutely nobody knows that of the 4 industries that were identified as critical for the US, casting's there. It's this high technology casting, which is low technology. And I think there's 3 startups working in this area, and we've all got different approaches. We're very much looking at fixing the skilled worker shortfall. But there's almost nothing happening in this area, and it is really interesting. It is hard to get people to see the value in it, and to see that, because it's just not in your face, but it actually is fundamentally in everything we do.
I think that is part of why what you're doing really speaks to me, is that based on almost no logic or data, I firmly believe that we have to be able to build things in the United States again, down to the base manufacturing and resource capabilities, mining and casting and forging and figuring out our power so that we can have bigger ironworks again. And, all of that stuff, to me, I am a simple man, but I'm like, we talk to people who do software in manufacturing. We talk to people who are doing hiring in manufacturing and training. That stuff is also all essential, and I don't mean to denigrate it, but there is an instinct, especially in the American venture culture, to say, yeah, cool, somebody else is going to do casting. So I think your illustration is perfect to say some people actually need to do the basic hard stuff, but in a modern, scalable way.
I've literally been told by VCs, I wish you were doing software for casting. And I'm going, well, this is the thinking that's got us into this problem, right? Is actually, and yes, the software for casting is super important, but someone has to do the hardware. Someone has to find out how do we actually make. And at some point we have to get away from the reticence to actually make and say, well, that actually is the fundamental. All the rest is peripheral. We make, and all these things can add on top of making, but making is the core, it's the foundation.
David.
And on that note,
yeah.
But
Thank you for coming.
Great. Yeah.
Thank you for coming by. Thank you for doing it in the middle. Were you making it? Was it a bit, or were you really having an earthquake while we were recording?
No, I don't know. I think we might have some strong wind here, but the roof was rattling.
That was the sound of the anger of American investors who did not get a chance to give you money in the seed stage, and put me on that list.
Awesome, man. All right. Have a good one.
Perfect.
And we will talk soon. Let us know when you're next in the States. Yeah, thanks so much for coming on. We'll talk.
I really appreciate it. Thank you, guys.